is the next question, number 25. If an ideal transformer has an inductive load element at port 2, as shown in the figure below, the equivalent inductance at port 1 is. Okay, so here we are asked to find out the equivalent inductance at port 1. So we are shifting to the primary side. Now because the ratio given to us here is n is to 1. So which means that there are n number of turns here and 1 here. So that is the ratio, which clearly indicates that the primary side has got more number of turns than the secondary side. So if we are to shift the inductance from secondary to primary, now you should know that if the load element was shifted to the primary side, so here is the load, right? So it is shifted to the primary side through port 1. Now port 1 is the primary side. I told you because of the ratio given to us as n is to 1. Okay, so this means that the impedance will be high and the current will be low. So that is the ratio that you will have to remember as well. Impedance is high and the current is low. Just an important point for the primary side of an ideal transformer. So if the load element was shifted to the primary side, then the effective equivalent inductance, we will have to find out the effective equivalent inductance. Okay, so we need a relation between the ratio given over here is the number of turns to the inductance, the load inductance given over here. So if you recall, when the load element is shifted to the primary side, the effective equivalent impedance has a certain relation. So the effective equivalent impedance has the relation of ZL divided by NS by NP whole square. This is our load impedance, okay, while these are the number of turns of the primary and secondary. So if we were to apply the same logic for the equivalent inductance, we will get L, because that's the load inductance here, L divided by NS, the ratio is 1, and NP is the ratio, 1 to N. So that's 1 by N whole square. So this gives us N square L. N square L matches option B. So for this question, the equivalent inductance at port 1 is N square L.